Good morning, folks. So we are not yet at start time. We usually start about 5 after as we wait for folks to turn up. I would ask folks to please go add yourselves to the attendee list, and we'll get going at about 5 after.
Hi, Ed. Can you hear me?
I can hear you.
Okay. I have mixed audio now. I have a microphone on my headset, and the sound is coming from the laptop.
And yet no echo.
Yeah, that's true. Let's see if I can. No.
So
yeah, we are not allowed to install the Zoom client on our laptops any longer, which means we need to enter through the browser, which is a kind of pain. And yes. But it seems like it's...
There's a lot of that going around, actually. I know people from a lot of companies who are running into that difficulty. So
True.
I partially solved this in that I actually do my open source work on my own machine. And so, you know, there's literally nothing there that is not either personal to me or literally public.
Right.
Hello.
Hey.
Let's make sure. I think it was Jan who mentioned that he was going to do a presentation today.
Yes, could you add that to the agenda, please, Jan? I'm really actually excited about that.
To add what to the agenda?
I think you would want to do a presentation today.
Yeah, you want the slides on, a link to the slides on the agenda or what? I can do that after the meeting.
Well, no, just stick an agenda item in there, so that when we get down to the agenda, we actually, say,
okay,
hey,
Right. Yeah. Okay.
Also, a link to the slides afterwards would be fantastic.
Yep.
That's always welcome.
We'll do that.
But at least put yourself on there so that we actually get to you. And I'm delighted to put that even before this week in NSM if you'd like. And just for folks, in case any folks are new to the meeting, we tend to run a fairly open agenda in the sense that we strongly encourage people to add stuff themselves, including adding stuff themselves during the course of the meeting. So, and once again, I encourage folks to add yourselves to the attendee list. The link is in the chat.
Yeah, some of our best meetings have literally started like that. Like, hey, there's nothing on the agenda. This is going to be a short meeting. And then someone comes with a fantastic topic, or in some cases, full-blown presentations of things they wanted to present. But
Yep. Cool. So we usually start about 5 after. To give folks a chance to turn up. So it'll be a couple, 3 more minutes. Could someone share the meeting minutes?
Okay, just before we get started, a reminder that this is a recorded call and the videos are posted to YouTube.
And again, just before we start, I also want to remind folks to please go add yourself to the attendee list. The link is in the chat. Is someone able to share the meeting minutes so we can all follow along? Thank you so much.
Fantastic. Let's get started. So, welcome to the Network Service Mesh weekly meeting. This meeting occurs every week at Tuesday at 8 a.m. We also have a PR review weekly on Tuesdays, which occurs every 7:30 through 8 a.m. Pacific. We have on hiatus a bi-weekly Asia-friendly time, which occurs every other week on Tuesdays at 8 a.m. Those have been put on hold temporarily. We also participate in the CNCF Telecom user group, which the next call is going to be on Monday, July 20th, according to the agenda. I'll double check that time because usually they usually happen every first Monday. Every third Monday has been canceled out, but I don't know if that's taken into effect yet. So I will double check on that. We also participate in the CNCF SIG network, which occurs every first and third Thursday of every month at 11 a.m. Pacific, which should be today, or sorry, that was last week. So there's one that's next week as well. We are, in terms of major events, we have HPE Discovered, where I'll be talking about Zero Trust Security. That'll occur sometime end of July. I'll let you know when that all happens. We also have ONES North America. There's the schedule has been announced. We are not participating in this specific one, but there's a lot of good information that comes out of it. We are also participating in KubeCon, Cloud Native Con, Europe. Nikolai and I will be giving a talk at that event. And as a reminder, KubeCon and Cloud Native Con North America, the deadlines were pushed back to July 12th. So make sure, if you haven't done so already, to get your CFP completed, and notifications will be sent out in September. We will provide more information on NSM North America as events unfold.
I have a little bit of an update I can give on that, not a complete one. I'm hoping, so basically the way co-located events are being handled is that the platform they had found for virtual events has limited capacity, and so we as a community will need to find our own platform. Now we do have sponsorship to pay for platform support, which is good. And so I'm hoping to be able to talk in the community next week about some of the platform options that are available to us for actually doing that. Now we will still be listed on the program. Normally we will still be listed as a co-located event on the co-located events page. It's purely a technical matter having to do with how many talks they can shove into the platform that they're using.
Can I raise a question regarding NSMCon Europe here?
Sure.
How we are going to organize this? As me and Rajab, we both have talks on the NSMCon, and I suppose it also should be pre-recorded. So do we have an end date for that, or it's not as the KubeCon organization? But
oh no, so we will be happening on day 0 still, at the same time as all the day 0 events. The thing I mentioned about platform per events that hopefully we'll be able to show some of the platform options next week. That would sort of give us space around the options. We may go with pre-recorded talks, or we may not. That's kind of up to us as a community to decide. I, generally speaking, am really curious what people's feelings are on that. I, as a personal matter, really enjoy audiences, bizarrely more than most people. So I don't really trust my opinion on that question. So I guess you raised a good question. Do we want to do pre-recorded talks, or do we want to do live talks?
Yeah, actually, that was I have someone feedback from people from OSS North America, and they share that with pre-recorded talk when it's virtual, it's much easier to reply questions that are asked during the talk.
Yeah, I tend to find that. I tend to find that as well. Yeah, I tend to find that as well.
Cool. So we'll make sure that gets added to the agenda for next week. We have to know what our platform's options are first before we can make a good decision on that, I think. In terms of so in terms of NSM North America and EU, so yeah, we'll get more information on that. But our NSM EU definitely still happening. NSM North America, we plan to have it. We'll get more details as we proceed forward.
So definitely slapping, but mechanical details are still being worked out. Exactly.
So we also have social media community team. Thank you to that specific team. They've added this particular time. There's no additional followers, or they've added 6 additional people that they're following out. They've posted information on CNCF, the weekly webinars, the variety of events that are going on, including KubeCon North America, CFPs. There are information about training and general information about Linux Foundation and 5G and telecom TV and so on. So it's a good place to follow and get some updates on what's going on throughout the broader community. And all of this information is also on LinkedIn. So if you prefer to follow on LinkedIn, that is perfectly doable. And the plan is to continue tweeting out these type of events and to provide information on NSMCon EU once we have more concrete information, and that'll also be streamed out over Twitter. And so we don't have any major announcements at this point, so let's jump straight into the agenda. Today we have SmartNIC data plane for NSM by the Ericsson team who are going to present. So you all have the floor. Thank you. Also, if anyone's talking, you're on mute.
Okay, yeah, sorry. I seem I cannot share my screen while you are sharing. Hello, can you hear me?
Yeah, sorry, messed up.
Okay, let me try again. Okay.
Victory.
Can you see my screen?
Mm-hmm.
Okay, great. Good. Then let's try to start the presentation. Okay, good. So welcome. Thank you for giving us the floor today. I'm representing here on behalf of a team in Ericsson, where two of the guys are working with Ericsson Software Technology, which is our branch basically that is dealing with the open source contributions. And myself and Stefan, we are part of Ericsson PDU, and we are kind of working together with the guys that are doing the actual coding. The talk today, or the presentation, is about the SmartNIC data plane for NSM. And let me briefly introduce you to why we are doing this work. What's the motivation behind it and the main idea. We are coming as Ericsson from an infrastructure organization in Ericsson that provides high performance execution platforms in the past for OpenStack, and we are now targeting also Kubernetes. And we have a couple of applications that require really high performance user plane throughput, and the standard networking solutions, be it kernel networking, but also DPDK-based vSwitch is not sufficient for their performance requirements. Which means that in Kubernetes today, the only option that they have is plain SRV. And for various reasons that you probably are all familiar with, legacy SRV is not a very good choice for networking, because it has a super tight coupling between platform and application, and it provides basically zero services and so on. We are dealing with multi-secondary networking today to support these applications with high performance. I'll come back to that in a minute, but we are looking into using NSM as a vehicle or as a tool infrastructure to provide more advanced data plane services to these applications at very high speeds. Which means the current NSM forwarders that we have in the kernel one and the VPP they are good, but they are probably not good enough for all the applications. If you look at the VPP specifically, we have the vSwitch in there. So we have a typically vSwitch performance with the packet copying cost between host and pod, but that in our experience typically dominates the packet processing cost and limits the throughput.
Yeah.
And what we are suggesting to do here is to actually offload the NSM data plane as much as possible to a SmartNIC to get rid of these, meaning we can support user space, network service clients, and service implementations, but we can also support kernel ones, because as I will show you in a minute, the solution supports both. In the same way, we get full PCI pass-through performance, both for the clients and the NSE implementations, no packet copying, and we don't consume host CPUs for the vSwitch. So that's the starting point. Any questions so far?
Just one minor technical question. When you said packet copying, it sounds like you're talking about the sort of the fact that it takes a long time to go in and out of the kernel, as opposed to something no?
No. I mean, this is about the DPDK type of interface, the user space interface between the host and the guest, which you have both for vhost user in the past into the VMs, but also with MEMIF. MEMIF does packet copy from the host.
Okay, so you're literally talking about the mem copy.
Yeah, the mem copy.
Okay,
correct.
Interesting. I'm surprised that that's more expensive than round tripping over the PCI bus.
Yeah, it may depend on applications, but we have done extensive profiling. And
I believe
at
you.
least
I totally believe you.
For the DPDK, for DPDK and vhost user and our DPDK applications running inside VMs, it is dominating everything, really, due to cache misses and the actual bad performance of the memory subsystem that has to handle all transfers.
Oh, anything that involves leaving the cache is a pure lose. I agree.
Yeah. Okay. Good. So recap. OVS hardware offload. I mean, with SmartNICs, there you have only so many different control planes to actually program what the SmartNIC should be doing. Some of them are super low level, and some of them are more higher level. And the one that has been most widely used in the past, and we have a lot of experience with, is OVS as a control plane for the SmartNIC and OVS hardware offload to the SmartNIC. That has been around for quite a couple of years, 5, 6, I would say, driven by companies like Mellanox and Metronome. It's all upstream in the communities, in OVS, in Linux, TC Flower subsystem, in OpenStack, and it uses the offload of the kernel data path basically through TC Flower. It has the very nice property that the control plane, the next higher level control plane, be it OpenStack Neutron or something else, is basically unchanged. This happens fully transparently to everything, and we are making really use of the feature of Open vSwitch to compile a complex OpenFlow pipeline into megaflow cache entries that can be very easily offloaded to hardware like a SmartNIC. So that solution has been around for a while. It is actually production grade, for example, in Red Hat OpenStack in the recent release has been around for a while, but now they have said it's production grade. Red Hat is also doing the same thing with OpenShift, with Kubernetes. They are going for the OVN as a networking backend with the OVN Kubernetes CNI for primary networking even, and that is fairly complex, and implementing hardware offload to the Mellanox Connect X5 SmartNIC as an option here. And we have been doing something much less ambitious. We have only looked at secondary networking so far with Multus using the OVS CNI and offloading that to a SmartNIC. And I'll show you a picture related to that next. So here's basically what we have been doing with the OVS CNI. Multus, as I said, so we are talking about secondary networks. Without hardware offload, the OVS CNI basically connects VTH pairs into pods as network interfaces. And with the hardware offload, what happens, the NIC is configured as in switchdev mode, which means the SRV virtual functions become, we call them smart virtual functions. They are no longer dumb SRV virtual functions. There's a representer device in the kernel that is being connected to the Open vSwitch, and all the vSwitch programming that happens in OVS is offloaded to the NIC itself when the first packet has been processed. So the first packet goes up to the Open vSwitch kernel data path, the slow path. The pipeline is being processed. The result of that is compiled into Megaflow cache entry, and that Megaflow cache entry is actually downloaded to the switch implementation on the NIC, so that subsequent packets basically are directly forwarded between the physical functions and the smart virtual functions based on the instructions from Open vSwitch. And in the context of this solution, what we are actually offloading is the L2 unicast forwarding, VLAN trunking and filtering, and the link selection for the bond. So the bonding is taken care of by the NIC itself, meaning the applications no longer have to worry about redundancy as they normally do when they use legacy SRV network interfaces.
No, this is good stuff.
So that's what we have been doing, let's say, in the beginning of the year. This has all been upstreamed to the OVS CNI, and it's available. Pull request is up there. And we basically decided to make use of this infrastructure and extend it to try to cover NSM data plane.
Cool.
So here's a representation of an example network service chain, let's say, in a use case that we are looking at, using still the VPP forwarder, where we have a client pod or set of client pods, and we have some kind of gateway load balancer entity, NSE, and then we have a front end, and that front end is basically acting as a breakout point to bridge between the NSM data plane and multi-secondary networks towards the external network DC gateway. That's one way of doing it. There may be others, and we'd love to talk about this, but that is the one that would work out of the box for us.
Yep.
And when we go to the SmartNIC, the picture would change as follows. We would get rid of the V-switch, the VPP V-switch. We would have an OVS forwarder with OVS on every compute node, every worker node. And instead of MEMIF interfaces into the pods, we would now have smart virtual functions that are being injected into the pods. And the forwarding, the cross connect, basically would be facilitated through the OVS forwarder.
Quick question for you on mechanical details here. The things you're labeling as SmartVFs, which I totally get why you've labeled them as SmartVFs. They're still showing up via VFIO in the pod, correct?
They, well, no. With the Mellanox Connect X5, there is always the MLX5 core driver bound to the PCI device. Yep. Which means they show up as a standard virtual function network interface in the pod. And you can run either a kernel application on it, or you can run a DPDK application. You can do both. You can even do both at the same time, but then you have to basically program some kind of filtering which packet goes where.
Okay, the reason I was asking is that the thing that we care most about, as you know, in NSM is what is the local mechanism that the pod sees.
Right.
The stuff that you're doing sort of below that line is awesome and really interesting. I just wanted to know whether or not we were seeing a new mechanism type show up.
I believe we need to have a new mechanism type.
Okay.
Because it is more than just a kernel network interface.
Yeah, that's definitely an interesting conversation that we would want to have. I would agree.
Right, right. Yeah, let's park that discussion.
Totally.
I have a quick question. This is Nikolai here. So, like a year ago, okay, maybe more, there was only one forwarder, and we were sitting down with my colleague Radoslav, and we're trying to figure out what are the next steps. I mean, what type of forwarder we want to add. And we were all looking at OVS and kernel and looking back and forth, and then we realized that actually what a forwarder needs to do is a handful of very simple functions. So having OVS is not really bringing any real value, at least back at the time when we were looking at it. So I'm interested to see, are you just using it for convenience here because you already have the infrastructure, so you just want to reuse that, or you find a real need to use something of more advanced functions here?
No, I mean, if you look at the functions that we do with OVS, they are really, as you say, they are trivial. We'll have VXLAN termination configured in OVS, and we do cross-connect by installing two OpenFlow flow entries that send packets between ports. So from that perspective, I agree. If the target would not be to offload the whole data plane to the SmartNIC, there is no point in introducing an OVS forwarder. Right? The OVS forwarder with kernel interfaces alone, there is no value. But the OVS forwarder with the offload of the OVS data plane to the SmartNIC has huge value. And that's what we're trying to show here.
Yeah,
because if you don't,
right? I assume you can't get rid of OVS anyway because you're tied to OVN. So at least for your primary networking as well. So that you still have that dependency on the side, but that could be orthogonal depending on how that gets implemented. Where we could you could ask it OVS to do something on your behalf, or have a data plane that is completely orthogonal to it. So either way will work for us. We just have to know the shape of the thing that you need.
Right. So what we are using, why we are using OVS is because this is a super convenient control plane to actually do hardware offload to the SmartNIC. If we didn't have OVS, we would have to do something completely on our own, and that is prohibitive cost. And it would be non-portable. We would be doing one thing and then going to another type of SmartNIC. We would have to redo things like that.
I think what you're saying is that you needed something to program the SmartNIC for you, and that OVS was conveniently at hand. And so you might as well, because even though OVS is overkill for what you're currently doing, it's just there. And so you don't have to do additional work.
Exactly.
Now,
exactly,
that said,
and it might be actually a good foundation to do more advanced stuff in the future also.
Yeah, there's a whole other interesting conversation here that I've had with some other folks in the past about having the SmartNIC itself provide some network services.
Exactly.
And that gets to be super interesting, and that's where you'd want something more sophisticated.
Right.
You know, I to my awareness, the Mellanox NICs are smart, but they're not like build a stateful load balancer smart. But there are SmartNICs that are that smart.
Yes. Then the question is OVS the right forwarding plane to program those? But I guess we should not jump into that discussion now.
Well, the beautiful part about it is we don't have to now, right? We're perfectly happy with whatever you choose to use for that.
Right. So new OVS forwarder. So that's work that we have already done, at least for the kernel part. We basically copied the kernel forwarder code base and then morphed it into what needed to be done in order to do the same thing for OVS kernel data path. We're using OVS VXLAN tunnels instead of kernel VXLAN tunnels. We have one tunnel per remote node. And then we multiplex the virtual wires through open flow rules, controlling the VNIs through tunnel ID. So it's slightly more scalable through that. Then we have an open flow controlled integration bridge there that we choose to call BRNSM, where we program the cross connect between local port and the VXLAN port, or two local ports just by two very simple open flow rules. And then we have two local mechanisms. One is the standard one, that is where we program VTH pairs. And then we need a different local mechanism to actually do the plumbing for smart virtual functions. That is that's work in progress currently. Implementation is fairly complete, but we need to start integrating and testing this.
Cool. This is fantastic.
Yeah.
No, it also strikes me if you're basically doing the sort of two simple open flow rules for the vWire, which is a smart way to do it. You probably get insanely good performance characteristics in the sense that you only basically ever bump a single packet, or roughly a single packet, up to the control plane at the beginning of time, and thereafter you're golden.
Exactly.
Yeah, that's really lovely.
I have a question.
What I see really basically in case of SRIOV, lot of functionality is more to make actually. I think you are extending further that functionality by moving NSM, OVS, lot of functionality to make that. So basically, I'll say something like a next version of SRIOV with more functionality, more to make them.
Oh yeah, like I said, there's a huge forward space for you guys here doing more interesting things on top of the initial work.
Yeah, but even the initial work is already quite good, because if you look at this picture here. So this middle part is the one that we already had from the OVS CNI. That is still there, and it works. And now we add the new integration bridge for NSM. And we add the tunnel ports to connect the remote nodes that run over this local endpoint interface, which is the VLAN that runs over the standard multi-chassis log that we have on the compute nodes. So we have full network redundancy here. We have VXLAN encapsulation, and we have the cross-connect functionality offloaded to the NIC. Which is already quite a bit, right? The NIC, the client itself or the NSE pod will just see a smart virtual function interface, a single one, and it will have direct connectivity to the service, fully hardware offloaded, including VXLAN encapsulation and redundancy. That's the beauty of the solution.
That's super exciting. You know, because again, this is as a matter of personal opinion, I've generally felt for a long time that we're sort of like the Mellanox grade SmartNIC Excel is actually doing things like V-wires, right? Because they can just absolutely push and pop tags on things faster than you're ever going to do anywhere else. Cool. So that's awesome. And so I presume that you probably have a set of well understood, because the performance of pushing packets via a Mellanox SmartVF and pushing and popping VXLAN, that stuff is really well understood performance-wise, correct?
Yes. Yes, it is. I mean, we have had, of course, we've been doing this for quite a while, and it's not without its ups and downs, because they do changes in the drivers and so on, and sometimes it brings sudden performance degradation. But yes, in general, even let's say the lowest measurements that we have done are still good enough to handle the user plane of our applications.
Well, this is awesome.
100 gig line rate, let's say, with medium-sized packets.
Mm-hmm. So this is fantastic.
Is this going to work just with plain OVS? Like, can I install it on my laptop without having any advanced NICs?
Yeah, no,
Perfect.
of course. I mean, you won't get any hardware acceleration.
Yeah.
You don't have advanced NICs, right?
I mean,
then,
like, it's not kind of hardwired to the Mellanox NIC. I mean, if you want to plug something else, you probably can do that also.
There are a couple of NICs that support the same kind of hardware offload from OVS through TC Flower.
Mm-hmm.
For example, the Netronome Agilio and maybe some others. Whether or not they are capable of offloading exactly the same type of functionality, including VXLAN encapsulation that we make use of here, that's a different question. For Mellanox, we are sure it will work. For many other NICs, it might not work, and that remains to be seen. If it doesn't work, if the hardware offload doesn't work, it will still work, because the fallback path is the normal kernel data path of Open vSwitch or TC Flower, for that matter. So you will definitely see it working, but whether you get hardware offload or not depends on how well your NIC is able to hardware offload this.
No, and that's actually a super important characteristic, because one of the things that's super different about the cloud native space versus what we were all used to before in the Cloud 1.0 stuff, right? In the Cloud 1.0, you would gently massage things until they worked. And so, if somebody didn't have everything just right, things just didn't work, and that was kind of the way it was. In the cloud native space, the expectation is things will always work, but you may have to massage them to make them perform. And so the fact that you always work is super critical.
Exactly.
Performance is nice, but it used to be that you had to do a lot of work to get it to work at all, and then you just perform out of the box. And here, everything just works out of the box, but you may have to do some work to get it to perform. So
I didn't get that. I think that you already answered that question, but I'm sorry if you did. But this SmartVF, how is it consumed inside? Do I need to have a DPDK driver for this? I mean, is there anything standard, or it's
no? It is. Yeah, it's a standard virtual function, Mellanox Connect X5 virtual function. So if your operating system has the driver for it, and all operating systems do, then you have a standard network interface that you can use in any way. If you want to consume it as with a DPDK application, you can do that, but then your DPDK application has to be compiled to include the support for Mellanox, which is not always enabled due to some extra dependencies that you have. But it's there. The driver is there. You just have to make sure that you build it accordingly.
Yeah, the Mellanox guys make amazing NICs, and they do so many creative things with their drivers that sometimes make them different from the other drivers.
They have a bifurcated driver model, which means that you always have a kernel driver bound, and then you can, on top of that, run DPDK application with the DPDK poll mode driver. Both drivers will coexist and collaborate.
Yeah, no, there's a lot to be said for that. Because there is a lot to be said for that. There's going to be an interesting discussion that we probably want to take offline on the Slack channel about like how we want to represent that as a local mechanism, because it is sort of a weird creature, and I honestly don't even know what my opinion is about how to represent that as a mechanism yet.
Yeah, as I said, I think that is a discussion that we should have.
I do have a question for you. You guys were doing VXLAN, and I asked this just because I know there are other people in the community who will be interested. Do you happen to know off the top of your head if the MLX5s can do SRv6 push pop as well?
Can you ask SRv6?
SRv6, segment routing v6.
You mean MPLS push pop?
Not the MPLS, but the IPv6 version.
No, I don't know. And I guess that that might be something that is not yet available. But I know that Mellanox have been quite, let's say, responsive. For example, they have implemented Geneve push pop for Red Hat for the purpose of OVN hardware offload.
Oh, that's interesting. Do they support the full Geneve? That is something interesting. And I presume they also do MPLS push pop, because we do have people who care about MPLS over Ethernet as well.
Yes, but I mean, all of this would have to be discussed and tested. I'm not sure.
No, this was purely a do you happen to know off the top of your head thing. No, this is not making, none of this is being major problem.
Okay.
Other people get to make it your problem, not me.
Yeah. So let me quickly try to complete the presentation. So from the control plane perspective, what we have today, and I'm pretty sure that also that will be a topic for discussion, is we have this let's say static model where we need to consume these smart virtual functions. These are in our world today, they are managed by the SRV network device plugin. So we have references to the device pools, and the client pod spec. These pod specifications are augmented with resource requests in order to allocate a number of smart virtual functions as needed, and then the init container in NSM will basically have functionality to pick up those allocated smart virtual functions and create local mechanisms and connect them to remote services through doing that. And in the process of doing that, the forwarder will then be invoked, and the forwarder will attach the smart virtual function representer devices to OVS and program the flow rules. Basically, that's what's happening. And that, of course, for the client, it's pretty straightforward. For the NSEs, the model is, let's say, a little bit questionable, because with this approach, which we have adopted for simplicity, it means we consume one smart virtual function per virtual wire. And the number of smart virtual functions is not extremely small, but it's finite. And so this model doesn't scale very well. So right now what we do is we basically create the NSE pods with a predefined number of pre-allocated smart virtual functions, and then when clients connect, we consume those pre-allocated virtual functions until they are exhausted, and then we are done. And in order to improve that scalability, what we are thinking about is to have yet another kind of local mechanism that is actually multiplexing many virtual wires over a single smart virtual function, using, for example, VLAN tags for traffic separation.
So that's actually an interesting approach to the problem. The issue you're getting here too on the NSE side is kind of an interesting one, and there have been some discussions sort of mulling a little bit on the early side how to deal with it. I would love to take some of that discussion offline as well,
sure,
into Slack, or even if we want to get together another community call for the folks who are interested in this stuff, because I've been kind of thinking about it this way. Please note this does not make this the right way to think about it. It just happens to be the first one that occurred to me, which is to think about it as your network service endpoints requesting, so think of it this way. If you think about a model where the network service is something you're getting from the physical network, and then effectively what I've been thinking about was what I would sort of call a via mechanism, where you can say, okay, I'm offering this network service via this other network service. Does that make sense?
Not yet.
Okay, so think of it this way. Your network service endpoint basically asks to be connected to some network service, like something provided by your physical network. And then it offers its network services via that physical network.
Okay.
So for example, the situation you described with doing like VLAN tagging on top of your VXLAN tunnel, for example, would be something that sort of fell into that category. But I think this is something where we need to absolutely have some conversations, because I'm curious to know more about some of what you've done here. It actually sounds like it's pretty close spiritually to some of what I was thinking about with the via mechanism, which is you may have a V-wire on top of which you multiplex a bunch of V-wires. I had not been thinking about it in terms of a different mechanism.
That is one way. Yeah, that's one way of looking at it, is like stacking things, but we have not done anything. What we have done right now is this initial approach, which is a flat model, and we just
working code is always a good thing, dude. I'm 100%
exactly.
in favor of working code. And you know, you guys are completely self-aware about where you would like to make the world a better place, and that's also awesome. But no, this is actually incredibly exciting. And then, sorry, I should let you finish your presentation.
Yeah, I'm almost done. So the rest of the part here is basically unchanged. That is the standard OVS hardware offload that happens then when the smart virtual functions are exposed to the pod, and then first packets flow, and then we have the normal packet punting to slow path, mega flow creation, and then offloading to the switch def. So nothing very exciting about this anymore. We have two examples here of how it would look like currently. This, as we said, we are not yet in the final stage of integration testing, but we have a client here that consumes a network service. And there's a second annotation here which tells us tells basically how many devices to request in order to use smart virtual functions rather than VETH pairs. So if now Dimitris and Pere, you have to help me. If this second annotation wouldn't be there, then the init container would fall back to using VETH pairs. Is that correct?
Yes.
Okay.
Yeah.
And also, even if the devices are exceeded, in the code there is a context that falls back to the VTH pair, so you don't get an error or something. But that could be changed also if we don't want that.
Cool. No, this is interesting, and the whole notion of like how you handle this annotation wise. We sort of taken the lazy route initially and said, if you're not using a kernel, if you're not using the kernel mechanism, then we presume that you're smart enough that we don't need to do this for you. And I think you've sort of taken the position here, which I think is more defensible, of saying, really, is that really what you mean? No, let's give people a little bit more mechanism, a little bit better choices here. And I think that's probably smart.
I like how you namespaced this as well. So you could say intel.com/whatever that resource is, and I think that's quite useful, because then you can ask for specifically the type of things that you want, and it gives us a hint towards what type of thing we may be providing you as well.
This is the name of the device pool in the SRIV network device plugin here, and I think it's particularly badly chosen in this example because it's actually a Mellanox NIC and it's not an SRIV net device. But
I wasn't going to point that out, but I saw that.
There are precisely three problems.
The problem is that in my environment. The problem was that in my environment I didn't have a smart visual function, so that was like the name of the
okay. So you should have faked it, Dimitris.
Exactly.
There are exactly three problems in computer science: cache coherence, off by one errors, and naming things.
Yeah, exactly.
This counts at
Good
least
point.
two out of 3, possibly all 3.
Yeah. Yeah, right. So I think there's one more thing that is missing in the client pod, and that is the actual resource request for those devices. Because unless you have created a webhook that actually
it's inside admission controller. So we take this, and because those resources are requested from the init container, that init container is created through admission controller. So we just read the annotation and we pass the resources.
Cool.
Yeah.
Cool.
So
very good.
I want to be super clear about something at this particular junction, right? Which is what you've done here is interesting and cool and intelligent, further extending the abilities of the init container and the web admission controller. All of that is awesome. The web admission controller is not the one true way to do this. I've had other people who've discussed wanting to have other ways of injecting the init container, and all of those are perfectly delightful and fine. And the init container is also not the only one true way of hooking these things up. You can absolutely do smarter and different things if you want. So as long as you've made a conscious choice to say, this is the way I actually want to do it, because this is actually the way I want to do it, I'm delighted. But if you felt like you had to do it this way because this was the way it was done, it's not nearly that constrained.
Right, and I think we have discussed this. We have chosen to adopt whatever was there and to enhance it. And actually, I believe that our use cases in many of our applications actually do not require more than that. They are perfectly happy to live with a static configuration that it makes use of an init container, and how this init container is created and injected, they probably couldn't care less. But I don't think we need a dynamic programmable interface inside the containers today to create these kind of smart virtual function virtual wires to network services dynamically at the runtime of the system. But that might change. I mean, this is very early stage. This is based on our knowledge and experience with those applications that we have, working with them, consuming multi-secondary networks. And if new options arise, maybe they will also be consumed. So I would keep this open.
Or if you guys have other interesting creative ideas, right? I mean, that I guess is my point is, new and creative ideas is the name of the game. And so do feel free to think of new things.
Absolutely. Okay.
So one last thing as well. This is not for now, but probably medium term. It would be fantastic to help you find a way to not have to specify the specific type of device, but to have that automatically negotiated as part of your thing. So instead of having to put like Intel.com, a specific technology, you can say, what is the name of your network service? And then the fact that it's Intel SROV or Mellanox or so on is in band with the set of with the set of requests as part of the capability. So right now, like, don't change anything in this path, but as we proceed forward, we'd like to try to investigate that path, because it'll make the code a lot more robust. So whatever you put in there, it'll consume whatever you have, and up to the level of whatever capability it has. So generally, what I tend to talk about in these areas when I'm talking about CNS with other groups is you publish into a manifest what's your payload IP, and part of your request is what is your mechanism. So these are in bandwidth with the request, and you allow your orchestrator to then help you load in the right thing. So again, don't change anything at this point on this, but this is something we like to help with if you think that is useful.
Yes, absolutely. And I think that was also our starting point. We were looking for a way to actually let the configuration of NSM basically decide which kind of device pool to use for smart virtual functions and to plug, and not leave this to the application. But such a mechanism was just not available. So we had to basically revert to something that we could control from the client deployment specification.
Yeah, it feels to me a little bit like what the second annotation is wanting out of life is it's wanting to suggest a different mechanism. And that
Yes.
and effectively you guys got something working, because there's still a lot of open questions about the best way to represent the SmartVF mechanism and whatnot. But I think you would get a lovely bit of generality if we could arrive at a version of that annotation that simply expresses a different mechanism choice, rather than just rather than a particular implementation. Now, it happens in your case because you're using Mellanox. That, to the best of my knowledge, Mellanox is the only people offering the SmartVF mechanism. But
I
there
don't
are
think,
lots of
I don't think, Ed, that this is about whether to select Mellanox or Intel. It's really to point out to a device pool where these devices that are appropriate for the task are collected and available, because that is the mechanism that we have in place today. Actually, I'm not in favor of exposing it here or asking the client to actually tell which pool to choose, because that should be an NSM issue.
Yeah,
NSM should be set up to have a pool of virtual functions set up for its own purpose, and the client shouldn't have to deal with it. The client should just have to say, I want a smart virtual function mechanism.
Exactly. That's exactly my point. Yes.
Yeah.
For this network service, I want a smart virtual function.
Exactly.
Because the other thing that strikes me in the back of my head is, you may arrive at places where you get multiple network services being plugged into the same pod, right? So, for example, you may plug in something that is what my friend Dave Barrick would call the data plane for the cache customers. The thing that has to be really smart, really fast. But then you may have a control plane thing that is just, it's HTTP, guys. How fast is it ever going to be?
Right.
And that may actually be perfectly delighted to use a normal kernel mechanism. In fact, it may only be able to use a normal kernel mechanism. So
yeah, I'm fully with you. Totally agree.
Oh, the other thing that strikes me as kind of amusing here is the degree to which. Never mind that. But yeah, this is all good stuff. And I think we should definitely continue some of this discussion on the Slack channel and see what we can do about sort of converging and moving some of this stuff upstream. Because one of the things I think we've really wanted is a sort of a diversity of approaches to handling some of the cross-connect stuff. And a lot of people have done good work on the kernel cross-connect, which is lovely. I'd love to get more diversity in that regard, particularly around things that handle some of the hardware things you're describing here.
Can I ask, are you using this device plugin concept of Kubernetes? Because this is something I have a problem with, because Kubernetes needed to schedule the pods. And if you need to define those before, then you lose a bit of the flexibility with NSM.
Yes, we make use of the device plugin.
Yeah.
And it also it solves the scheduling issue.
Yeah, that's the thing. It solves the scheduling issue, but I know, but it forces you to declare this stuff before you actually defines the NSM data, I think, in a way.
Well, so there have been various thoughts around what to do around that. You've seen some of the stuff we've been thinking about in terms of SRIOV VFs, which have exactly the scheduling problems you're referring to are exactly isomorphic. And
yeah,
so
it was a long thread, like half a year ago about this, wasn't it?
Yeah. The thought there was, the thought there was, rather than talking about the device as intel.com/SRIOV net device, which is a terrible concept, right? Because again, one of the points I make to people repeatedly is literally no one actually wants an SRIOV VF. What they want is a fast path to something in their hardware network, in their physical network. And so describing it in terms of the implementation detail is a terrible description. But we were looking at naming the resources something like, a network service registry domain as a name from which you can then request any of the services in that network service registry domain. Was kind of how we were thinking about that. And then your device plugin simply advertises out, hey, I have available, the network service registry domain of, dc1.example.com. You're like, great, I want a network service from dc1.example.com, and you get scheduled there. Does that make sense?
Yeah, you mean that you take your resources, you put them into NSM, and you let NSM publish it to Kubernetes, or what did you mean?
Well, you simply change how you think about the resources, right? So SRIOV is an implementation detail. It's a great thing. I love SRIOV, but it's an implementation detail.
Yeah.
What's really interesting from an NSM point of view is what is the domain of available network services via this thing, right? What's the domain of available network services, and potentially what are the capabilities that I need, right? So we've talked about it often. So rather than asking for in your on the right under resources, rather than asking for intel.com/intel-sriv net device 2, you would ask for something like dc1.example.com/mlx5 or /100 gig or whatever the capability is. 2.
Yeah, but that would mean that we shouldn't use like Intel's DP API plugin for the SRV. We would instead write something.
Their plugin will let you specify the name of the resource.
It will, but it will deploy itself when it sees the hardware. Maybe you would like to go. I don't know that. This is what I mean. Maybe if I define a lot of services in NSM that has like certain characteristics, I could let NSM put this into Kubernetes.
One thing is the service characteristic. That may depend on how the NSE is implemented and what the NSE is using as local mechanisms. Yeah. But as a client, I'm actually decoupled from that, right? I want a local mechanism of the specific type. It could be an SIV virtual function that it's a smart virtual function, or it could be a kernel, or it could be a DPDK mem if that's the client way of looking at it. And then on top of that, I want maybe access to a service with certain service characteristics also.
But suddenly you get 3 different like parameters, don't you? A client needs to specify the name of the service, the type of mechanism, and the device plugin, like a certain device from the Kubernetes to get scheduled.
No, I think what we should get rid of here is that the client specifies the device. I think what NSM should do, if NSM is being asked for a smart virtual function type of local mechanism, then it knows which is the device pool that it should use. And then it can inject the corresponding resource requested into the pod spec and have the scheduler do its work.
But then you would need, then this would only work for the admission controller, because then you can manipulate the manifest of the client. But can you do this for a dynamic client? You cannot do that.
No, dynamic will be difficult, because once your pod is scheduled, you're bound to what this host can offer, right? I mean, you can't conjure SmartNICs out of the air. If the host doesn't have any, or if all its smart virtual functions are already used, then you're.
I agree, but maybe I don't know. This is the problem, because even if I would go around and say I would encode it into the mechanism, I still cannot know the dynamic numbers. I mean, how many of these devices are available at a certain point in time?
No. Either you have a fixed number, or you have you do like we suggested for the NSE, that you say pre-allocate. This is the maximum number that I want. I want them all, and
but then we lose.
Then I manage them on my own, basically, until they are.
Guys, we've run right up against time, so we're going to have to take this offline. But I think you just sort of illustrated the degree to which there's a lot of interesting stuff here. It would probably be useful if you could add some of these topics to subsequent agendas as well, so we could discuss them in the community call, because I think that would be interesting for everyone. And in addition, we can chat on Slack in between times. Does that make sense?
Yeah, it does make sense. We have a bit of a problem with the vacation period, I guess.
Yes, I keep forgetting you live in a civilized country.
Vacation? What's that?
How is that actually going in Europe, given the current state of COVID stuff?
I mean, in Germany, many people are making holidays in Germany, so which means our destinations are super crowded compared to what they usually are.
I think it's same in Sweden. People are staying at home with us.
Yeah, we've got sort of a similar thing in the US. We just had the 4th of July weekend, and a whole bunch of people who normally would take the whole week off, so we're sort of saying, so what exactly am I going to do? I can't go anywhere. I can't The most amusing thing available at home is actually work.
Let's close up the meeting so that we can get people on their way. But we can stick around if you want as well. So
yeah, let's. I would love to spend 5 more minutes to talk about the way forward, and then we can close.
Also, can you make these slides available? Are these available somewhere?
Yes, yeah, we will do that.
So I would actually ask you, basically in the meeting, is please put a link to the slides and also please link the repos you pointed to, because I know that there's a lot of people who are going to be interested in this topic.
Yep.
Yeah, we can go another. We can go for a bit longer. Just as want to thank everyone who's able to show up, and if you're able to stick around, fantastic. If not, we understand. But anyways, yeah, please continue.
So what's your proposal and recommendation for the next steps?
Oh.
So for next steps, I would say let's talk through some of these issues. Let's also talk about sort of some of what your thoughts are about where you would like this code to eventually move to. I would sort of describe it as being some forward evolution of it being extremely welcome in the network service mesh organization proper. But it's up to you guys if you want to do that. And please note, the reason I hedge with some forward evolution is, as you guys have already acknowledged, there are places you would definitely want to polish the code before sort of taking it into more generic use. So that's definitely forward steps. And then you may also want to look at getting plugged into some of the stuff that's starting to land with the new SDK bits, because we've got some work going on with the SDK SROV and whatnot as well, because I think that's going to also, with the multi-forwarder support, be much more flexible for what you're looking at here. But those would strike me as excellent next steps. I guess the important part is you guys have done the intelligent thing and you've got a proof of concept working to show that this is a good idea. And so now we're sort of like, how do we move from proof of concept into upstreaming if that's actually what you desire? Now, please note, you don't have to upstream. That's up to you guys. But if you so desire, we would certainly love to find a good way to fit you into the broader NSM organization.
Yeah, I would say the intention is to upstream this.
Oh, good. Now, and one of the nice things about the SDK stuff, which is rapidly coming together, is because that's going multi-repo, it's a much more flexible environment in the sense that you could go and have a repo related to, say, the OVS Forwarder, and we've also already established a tradition of having sort of repo local committers on things and whatnot. So that would become quite interesting as well. But I think we are a bit over time. I want to be respectful of folks' time. We can definitely take these into conversations on Slack. Do take some of the particular subtopics, and I would love to see them added to subsequent agendas for discussion, because I think that gets to be super interesting as well.
Okay, so next week I will still be there, and I guess also the other guys. So we could again schedule a time slot for maybe not the entire duration as this time, but a bit shorter to touch to go back to a couple of these topics in more detail.
Part of it may just be reading out some of the discussions we've had in the interim on Slack.
Okay. Okay.
All right. Cool.
Right. Good.
Talk to you later.
Thank you very much, guys.
Thank you.
Bye-bye.
Awesome. Thank you.
Bye.
Bye.